Hello everyone. Now I'll continue with the session 3 of metal casting and welding of module 3. Now in today's session I will going to discuss on degasification in liquid metals. We are well known degasification is a process to remove the dissolved gases which are present in the molten liquid metal. See, and this whatever liquid molten metal that is in when comes in contact with the air, as usually contains certain dissolved gases, generally nitrogen and oxygen. And these whatever the gases which are very compactably, which may affects to produce a sound casting. See, that's why on solidification, the elements may recombine to form a molecular gases, and in doing such whatever the activity, there may be a chances of getting some gas holes like blow holes or pinholes which have been projected inside the casting, resulting casting defects. That generally which may affects the solidification parameters also. See, since it is not possible completely to prevent or eliminate absorption of gases in the melt during melting of the metal in a crucible. And see, generally a vacuum melting which is used nowadays for preventing dissolution of these gases in the metal to eliminate certain casting defects. See, these are some of the sources of the gases in the liquid metal and their prevention. Furnace atmosphere, right? Furnace charge, ladles, furnace to ladle or ladle to mold, and in the mold, when we pour a molten metal into the mold also absorbs certain gases. Depends on whether the mold is dry or moistured or whatever. Now, see, for whatever this furnace temperature, again, if we again depends on the type of metal to be melted in a suitable furnace. Again, depends on their melting temperature. For example, if we melt an aluminium, we are well known. The melting point of aluminium is 660 degrees centigrade. Then we need to heat up to an 700 and plus temperature, then we need to decrease it to its melting temperature, right? And a furnace atmosphere is also very important. The furnace surrounding should not have any absorption of gases or moisture and so on. Even furnace charge, during charging a furnace, right? See, we need to uh, put it where dried uh, raw material. The raw material should not have any impurities or grease or moisture content and so on. See, the ladles very popularly we have been known. These are bucket-like structures, shape structures which have been used for pouring a molten metal or carrying a molten from the furnace to the mold surface. And ladles also should be clean, and it should not have any other impurities, and generally these ladles should be preheated. And next is furnace to the ladle and ladle to mold. Again, when we carry molten metal from furnace to ladle or ladle to the mold, again quickly we need to take out and we need to immediately pour into a mold cavity. And in during in the mold also, again it may be a green sand mold or a dry sand mold or whatever metallic mold and so on, depends on their its mold atmosphere and as well as its surrounding and as well as mold materials which you have been used. Now we'll look into certain different methods of degassing. uh, the two different methods which have been used, that is flushing and vacuum degassing. Again, vacuum degassing has been subdivided into static bath treatment, induction degassing, stream droplet degassing, and fractional degassing. Now we look into flushing. It is popularly we call it as an gas scavenging. You are well known, right? Scavenging is what in an IC engines you might have studied in your earlier classes in the thermodynamics. Scavenging is a process of removing unburnt gases. But in the same way here, we are taking out certain unwanted gases away from the molten metal. That exactly a gas scavenging with an inert gas is one of the most effective method of extracting dissolved gases from the molten metal. Generally, an inert gases such as chlorine or nitrogen, helium, or argons, which have been generally used in practice for degassing non-ferrous metals. While carbon monoxide is generally used for ferrous metals and nickel base alloys. Now, see, this is a typical flushing process which have been generally adapted during melting of a metal before pouring into an whatever liquid metal into the mold cavity. See here, a gas supply, right? A hose or a graphite tube which has been used. Right, this is a crucible which contains a liquid metal, and these are some of the bubbles, gas bubbles, which have been shown. See here, what happens? See in this gas uh, pipe, that is a graphite tube. See an inert gas which has been supplied, right, from the storage tank, uh, and whatever the gas which is being directly supplied into the liquid molten metal to what extract these whatever the bubbles. See these whatever the inert gases which will mix with this liquid metal and dissolve these gases, these whatever bubbles, and the rate of degassing again depends on the rate at which the gases diffuses into the gas bubbles. This is one of the most popular method, we call it as a flushing. And in vacuum degassing, again it's a most popular technique or a method of removing dissolved gases in the molten metal at lowering pressure inside the vessel, that is in your crucible containing a liquid metal under the presence of vacuum. By supplying certain vacuum, we can extract the gases which are present inside the molten metal. See, and moreover, it is very particularly used in steel foundries for degassing hydrogen and oxygen from the liquid steel. See, if oxygen which is present in the steel, which may produce certain defects, so then definitely we need to extract this oxygen or hydrogen. And moreover, uh, steel have been refined in a vacuum, which are characterized by homogeneous structure, generally we say, and low content of non-metallic inclusions and low gas porosity. Now, see, one of the most popular method of vacuum degassing is a static bath degassing process. See here, you can see the crucible, right? And this is the vacuum chamber, and which has been connected to a vacuum pump. See here, when the ladle has been trapped with the molten metal which has been placed within a chamber, sealed with an evacuated lid, right? Filled with a vacuum, right, from the figure A. And similarly, see in the one more setup which have been shown in the figure B, that is the process which although time consuming and requires additional equipments, which may be simplified by sealing this whatever tapped ladle, right, this whatever the ladle which this crucible which they have been eliminated, in the same way this entire crucible they made it in a fashion of a ladle, and it has been connected to a vacuum pump, see, which has been simplified. A tapped ladle itself with the covers a particular vacuum pump at the top of the lid. So next, induction degassing. See in the furnace, whatever the crucible itself has been housed or it has been installed with certain induction coils surrounded by the crucible. Say, and this whatever a crucible surrounded by this induction heating coil, this entire coils which have been sealed with certain rapid evacuated vacuum, and the molten metal has been transferred from melting unit into the crucible where the current flow through the coils. See, you can look into the path of the current, right? See, and the magnetic field that induces a eddy current, and a circular electric current produces steering action. Without a steering action which has been created within the molten metal to extract the gases which are dissolved inside the molten metal. See, this is one of the most popular method, right, in vacuum degassing. Next is a stream droplet degassing. See here, say this generally adapted in bottom pour furnaces. See, the molten metal from the ladle, right? This is the ladle has been poured down into another preheated ladle. See here, this is one more preheated ladle which has been placed in an evacuated chamber, right? And now from the bottom pouring of the molten metal has been poured with a uniform rate at certain small droplets of molten metal, and this whatever the stream flow into the vacuum chamber, suddenly this whatever molten metal exposures a liquid stream in the vacuum chamber leads to a very rapid degassing due to an increased surface area created by a breakup of streams into droplets, and these droplets does not have any gases, and which may eliminates the gases and to obtain a pure liquid molten metal, and this process helps the hydrogen gas dissolves in steel to be evacuated by using a vacuum pump. This is the most popular method which has been used in steel foundries. Next is fractional degassing. See here, this method is compared to an earlier method, that is a stream droplet method, is quite a complicated one. But generally, an inert gases which have been used it, right? See, you can see the inert gas supply here, right? And this is a molten metal which has been kept it onto here, and another onto the diagonally opposite onto the upper portion it has been connected to a vacuum pump. See here in the ladle, when the molten metal to be trapped and it has been progressively degassing by certain treatment, that is a fraction of metal has been separated by a pump, uh, that is a vacuum vessel which has been kept it at the top of the ladle, and fractional degassing level of the molten metal in the vacuum chamber has been determined by atmospheric pressure. So atmospheric pressure is very important, and which will determines its a fractional degassing level, and molten metal which flows down back to the ladle, producing continuous circulation of the melt and resulting removal of gases. See, as a molten metal, you can look into this. When we supply inert gases, these inert gases which will again reduces the gases already which are present in the molten metal, and the pure molten metal which will enter into the ladle, and this whatever the molten metal that is without any gases, straight away you can pour into a mold cavity to obtain a defectless casting. And now we look into certain multiple choice questions. First question: the term degassing is basically employed for optimizing the use of materials used in production of casting components. Options are true or false. It is definitely a false. And which of the following problems arises in the die casting that can be solved by having vacuum die casting? Options are overheating, interruption in progressive solidification, air in the cavity, difficulty in the cooling of casting. See, by overheating, right, we cannot arise as any problem, right? Then interruption in the progressive solidification, it is also a no. And next is air in the cavity. See, air that is plays a very important role. See, if it is any air which is present in the cavity, which may have certain problem arises during vacuum die casting. That is the option is C, air in the cavity. Next, third one, refractory coating to the metallic mold helps in reducing chilling effect on the casting. Definitely, the statement will be true or false. It will be definitely a true, because metallic mold is made up of metal capable of withstanding its high temperature. That is melting temperature of the molten metal. And if it has been coated with certain refractory, this refractory coating, what happens, it keeps that entire metallic mold to for a longer period of time to keep it hot. So then definitely the option is A, true. Next, fourth question. The scale of segregation cannot be reduced or avoided by implementing any kind of method. See, these options are true or false. It will be a false, right? See, then generally there will be a very little segregation ahead of dendrite tip because of main partition of any sort of solute trapped between the dendrite structure of a side arm. See, the scale of this whatever a segregation, right, which may decrease or decrease by increasing the solidification rate. See, then definitely it will be a false. Fifth question, which of the following gases is used in the method of recirculation degassing? Hydrogen, nitrogen, argon, and oxygen. See, generally they are using an argon, that is an inert gas, which has been recirculated for degassing to dissolve that gases inside the molten metal. The sixth question, casting which is cooled quickly generally have coarse grain structure. Whether the statement is true or false, definitely it is false. Thank you.